Hello. So let's continue on page 2 of the chapter 6 practice test. I know I started number 9 on the last video but got cut off, so I'm going to start back from the beginning. So we have nothing common in the radical. So that means we should separate them up and simplify each one individually. So that would look like cube root 8x over cube root 9y. So let's go ahead and break that down. 8 is 4 times 2, which is 4 is 2 2's and then another 2 and then an x. 9 is 2 3's and a y. So I always simplify before I rationalize the denominator. That way I don't have these big, huge numbers to try and multiply. I make it as simple as possible first and then save work later. So I'm looking for triples. So you can see there's a triple under the cube root. So remember, 3 2's come out as a single 2. So this is going to turn in the numerator to 2 cube root x. The denominator, I don't have enough 3's to get out of jail or enough y's to get out of jail, so that's going to stay 3 squared y. And I'm leaving it with exponents because you'll see why on the next step, or you might remember from class. We need to make these perfect triples because rationalize the denominator means get rid of the radical in the denominator. And the only way I know how to get rid of a radical in the denominator is by making it into triples. Because if I have 3 3's and 3 y's, then they'll pop out of the radical as a 3 and a y, and there won't be a radical left. So before break, we did that exercise where we said, okay, what's missing? We have 2 3's, but we need 3 3's. So that means one more 3. So now I have 2 plus 1, 3 3's. I have 1 y, but I need 3 y's to get out of the radical. So I need to add in 2 more y's. And whatever I do to the denominator, remember I have to do the same thing to the numerator. So I'm going to multiply them both by cube root of 3y squared. So let's see what the numerator becomes. 2 is the only thing outside. Cube root 3. So now we multiply what's under the radical. 3x y squared. Under the denominator, we now have 3 3's and 3 y's. And this is the whole reason we did that last step. Whoops. Sorry. This is the whole reason why we did that last step is because look it, they're both going to come out. If I have 3 3's, it comes out as a single 3. If I have 3 y's, it comes out as a single y. So now I won't have a radical in my denominator. And that's what rationalize the denominator means. Remove the radical from the denominator. So make a perfect square if it's a square root. Make perfect cubes if it's a cube root. So 3 divided by 3 is 3 to the first. 3 divided by 3 is y to the first. And look at that, no radical in my denominator now. And that last semester was one of the most missed problems on this test. So that is a good one to put a star by, highlight. Okay, so the very last thing we learned before spring break was number 10. So we learned how to get rid of single radicals like we did on number 8 and 9. But then we learned how to get rid of two radicals in the denominator. Anytime there's two radicals in the denominator, we have to use, or not just two radicals, two terms. One could have a radical or both could have a radical. So terms are things separated by addition and subtraction signs. So there is indeed two terms. So do you all remember from before spring break what the conjugate is? The conjugate is the exact same thing, but we change the middle sign. So radical 10 plus radical 5. But whatever we do to the denominator, remember we have to also do to the numerator. Exact same thing. So always make sure these signs are different, because if they're not conjugates, we can't get rid of the radical. Only with conjugates will the radical disappear after foiling. So then we also learned that in the numerator, this is going to be a distribution problem. So this is going to be distributive. But in the denominator, because these are conjugates, we only have to do F and L. It's the only time you don't have to do the whole FOIL is when they're exactly the same, but one's minus, one's plus. So we only have to multiply the first terms and the last terms. Okay, so let's see what we have. So in our numerator, we're going to have square root of 20 plus square root of 10. In the denominator, foiling, or just F and L, from F, we get square root of 100. From L, and remember, do the sign first. A negative times a positive is negative. Square root 5 times square root 5 is square root 25. So now, hopefully you recognize that 3 of those 4 radicals can be simplified. 2 and 5, there's no pairs there, but 20 is 4 times 5, which is 225. So we have pairs there. This is a perfect square, and this is a perfect square. So the pair here would be 10 times 10. The pair here would be 5 times 5. So 3 of those radicals need to be simplified. So 20, like I said, is 4 times 5, which is 2, 2, and a 5. Plus radical 10 doesn't have any pairs, so we're going to leave it just like that. And a square root of 100 is just 10 minus square root of 25 is just 5. Then we look for pairs, and we have a pair right here. So that's going to come out as a 2. So 2 2's under a square root come out as a single 2. So that's going to leave us with 2 radical 5 plus radical 10 in the numerator. And in the denominator, just 5. So there is our answer. Not bad, right? So don't forget conjugates. We use conjugates in 2 different scenarios. We use conjugates when we're trying to get rid of radicals in the denominator, and we use conjugates when we're trying to get rid of imaginary numbers in the denominator. Okay, let's move on to number 11. I'm going to do 2 different problems for number 11. I want you to do this one. And I want you to do this one. Because I may put one of these on the test, or I may put both of them. And they're both good because they use the exponent rules, and that's all this problem is. It's just exponent rules. So on your test, you're going to be required to take pictures of your work and send it to me right after the test. So the work required on this would be to show me you know the exponent rule. So the exponent rule for multiplication says keep the base the same and add the exponents. So that's the step I want to see, because that's your work step. Then you can get out your calculator. Here, let's get it off that shadow. And just do 1/3 plus 1/4. So 1 fraction bar 3 plus 1 fraction bar 4, 7/12. So that means the answer, keep the base the same and write your exponent. And make sure that 7/12 is up in the air. It's not x times 7/12, it's x to the 7/12. It's an exponent, so it needs to be up in the air. The second one is division. So just like the multiplication problem, you are required to show work, so show me what you're going to do. So in division, we learned back in chapter 4, we keep the base and we subtract the exponents. So this shows me you know the rule. Then you go ahead and type it in the calculator. So for this one, I guess we'll be over here again. Well, it's the same thing, so I'm just going to hit the up arrow and change that to subtraction. So it's 1/3 minus 1/4, which is 1/12. So if it's multiplication, remember to add your exponents. If it's division, remember to subtract your exponents. So either or both of those are fair game for the test. Okay, this next one is also on the most missed list. Actually, 10, 12, and 14 were all highly missed last semester on this test. So I would bubble those to pay a little extra attention to them while you're working them. Okay, so for number 12, so 10, 12, and 14 were the most missed on this page. Okay, for number 12, first thing I notice is there's a negative exponent. So back in chapter 4, we learned that when there's a negative exponent, you need to reciprocate the base. If it's a whole number, you put the base over 1. If it's a fraction, you just reciprocate the fraction, and then that makes the exponent positive. Don't reciprocate the exponent. You reciprocate the base, which makes the exponent positive. So that should be number 1. So the 27x to the 4th goes to the numerator. The 8x to the 7th goes to the denominator. And that makes our exponent become positive 1/3. I'm going to shut my office door real fast. I have a dog that snores and I could hear her, so you guys probably could too. Okay, so 27x to the 4th over 8x to the 7th. By reciprocating the base, that made our exponent positive. So this is a step most students forget to do, and they turn this into a horrible, long problem, because this problem is 2 steps. That's all it is. But if you don't do this initial step here after reciprocating, you can make it into a very long problem. So, order of operations says, please excuse my dear Aunt Sally. Do parentheses first, and that's what a lot of students don't do. What that means is do any operations that are in there, simplify, and students look and go, oh, no, can't be simplified. Well, that's incorrect. It can be simplified. It's the same problem as this. It's a division problem with base is the same. So when we were in chapter 4, I gave you a little